All right, on to our next section. Get this full screen. Okay, 4.3, area and definite integrals. Now we're going to find the area under a curve from A to B. So we're going to have those numbers again, where we start and where we end. Okay, so there are steps to doing that. Your steps are, number one, find any antiderivative. By that, they just mean find the antiderivative. Then evaluate that antiderivative at A and B, and then subtract the two. And that will give us the area under the curve. Okay, and I'm going to show you in a minute. You'll notice they don't have a plus C in here. I'm going to show you in 1 minute why that is. Okay, so we have this function we want to find the antiderivative of. So antiderivative of x squared plus 1 dx, and we want to find that on the interval from -1 to 2. So yes, you put your numbers at the end of this integrand symbol. And yes, you are going to have to learn how to write that. Okay, so when I take the antiderivative, now you'll notice this symbol does not end up in my answer. Once I've done it, it's gone. Okay, so we have x cubed over 3 plus x. Okay, and we'll go ahead. We're going to put a plus c in, but I'm going to show you why you're not going to need that for these problems. So step 1 was to find the antiderivative. Step 2 is to evaluate that. So we're going to evaluate that at -1 and at 2. Okay, and then we're going to subtract the 2. Okay, the bigger one is going to go first. So 2 cubed over 3. Now you're probably going to do this in your calculator. Plus c minus -1 cubed over 3 plus a -1 plus c. Okay, why did I put this second part in parentheses? We have to remember to distribute that negative. Okay, when we do that, we're going to have 2 cubed over 3 plus 2 plus c minus -1 cubed over 3 plus 1 minus c. What is going to happen with those c's? They are going to add to 0 every single time. So when we are evaluating these, we are not going to need to use the plus c when we have numbers. These are called definite integrals, and we don't need the plus c. Okay, so let's go ahead and get numbers. So we have 2 cubed over 3 plus 2 minus -1 cubed over 3 plus 1. We've already distributed, so we don't need to do any more sign changes. So we have 8 over 3 plus 2 minus, well, 1 cubed, -1 cubed is still a -1 over 3 plus 1. So we should get, let's change everything into thirds. We have 8 thirds plus 6 thirds. Now, the easier way to do this is going to be to, 3 thirds. Okay, so 8 and 6 is 14, 15, 16, 17, 18. So we have 18 thirds, which simplifies to 6. I personally would do this in my calculator. Go ahead and put this antiderivative into the y equals, and then put the two numbers, the 2 and -1, into your table, and just get the values and subtract them. Okay, so, and this is basically just a definition, says exactly what we just did. The definite integral from A to B, And again, you have A and B. Those numbers will be written at the top and bottom of your integrand of f of x is, remember this capital letter is the antiderivative. So the antiderivative evaluated at B minus the antiderivative evaluated at A. Okay, so here is another one. Right, we're not going to do that one because I don't like that they have letters. Okay, so let's try these though. So first, let's get an antiderivative. So we have x squared minus x. So we have x cubed, add 1, divide by that new exponent, minus, well, that's just an x. So we have x squared over 2. Okay, so that's your antiderivative. Now we want to plug in values. Again, I would put this in my calculator, which is what I'm going to do right now. So y equals, and we're going to have x cubed, divide that by 3, minus x squared divided by 2. Go to the table, and I'm going to plug in 4. And when I plug in 4, I get 13.33 minus, when I plug in 1, sorry, negative 1, excuse me, I get negative 0.833. Okay, that means we're going to add those two things together. So 13.33 plus 0.833, we should get 14.1. Okay, on B, antiderivative of e to the x. Well, to get the antiderivative, write it exactly as it appears. Divide by the derivative of the exponent. The derivative of the exponent is going to be 1. Okay, and then we are going to evaluate this at 0 and at 3, meaning I'm just going to plug it into my calculator. 1, 4, just plug e to the x into the y equals, actually I'm going to do this one without doing that, because we can actually just leave it this way, and you might like that better. So e cubed, that's e to the x evaluated at 3, minus e to the 0. What is anything to the 0 power? Anything, doesn't matter what the base is, if it's to the 0 power, it's 1. So we get e cubed minus 1, and that is a fine answer as well. Okay, and on this last one, I have the antiderivative of 1. In this case, our variable is x, plus, now we're going to have 2x squared divided by 2 minus, and 1 over x, the antiderivative is ln x. Okay, let's go ahead and simplify that. So we're going to have x plus x squared minus ln x. And we are going to evaluate that at 1 and at e. So we have e plus e squared minus the natural log of e. And from that, we are going to subtract 1 plus 1 squared minus the natural log of 1. Okay, so we get e plus e squared. The natural log of e is 1 minus, okay, we have 1 plus 1 squared, so that's going to be 2. And then the natural log of 1 is 0. So I have, that will be minus 2. Okay, this whole thing in the parentheses is going to equal 2. Okay, so e plus e squared minus 3 is your final answer. Okay, again, you can also use your table and plug in e and 1 to your table to get that answer and get the decimal approximation of that, which, let's see, that would be I believe that is going to be approximately equal to 7.11. All right. And we did that on the last page. Did that one. Okay, here are some more for you to practice. Again, the answers to these will be in the notes that are posted online. And let's do one more, though, together. We'll go ahead and do this one. So we get 2x to the 4th divided by 4 minus 3x squared divided by 2. Let's go ahead and simplify that. So I get 1/2 x to the 4th minus 3/2 x squared. And I need to evaluate that at 2 and at 4. Okay, so go ahead and put that in your calculator. I have okay, and when we put in 4 and we put in 2. Okay, I got, I think that's right. Okay. Okay, and I got 104 minus 2, which is 102. All right. Fundamental theorem of integral calculus. All this says, it's a big fancy way, this symbol right here means summation, which means add them all up. Okay? This is the heights. This is the widths. And we're multiplying those two things together. So all this is saying is add up areas of rectangles. And if we add up an infinite number of rectangles, which is what this limit is about, then that will give us the antiderivative. Okay, so that's the fundamental theorem of integral calculus, which just says those Riemann sums that we were doing. If we can make those rectangles small enough, so small that there are an infinite number of them, it equals the antiderivative. Okay. If we look at this example, predict the sign of the integral by examining the graph. Okay, so this is the area between the graph and the x-axis. So we have this area here, we have this area here, and we have this area here. There is more graph below the x-axis, which is the negative numbers. So we would actually think that the answer to this would probably be negative. So oops, let's go ahead and try it. So we had, if I can extend the page here, we had negative x cubed plus 3x minus 1. And it went from -1 to 2. Okay, so our antiderivative will be negative x to the 4th over 4 plus 3x squared divided by 2 minus x. We are going to evaluate that at 2 and -1. And minus x. Okay, so we get, when we input 2, the answer is -16, minus, when you input -1, you get an answer of -1, so we'll add those. So our answer is negative, it is -15. Okay, now negative numbers, as far as areas, you've always been told that you can't have negative numbers, but in this case you can, and in this case it gives you a lot of information. For example, on this next one, we are talking about profit. Okay, so they give us the marginal profit. Remember, marginal profit was a derivative, so we're going to go backwards to the antiderivative. But what would profit tell us if it was negative? It would tell us that we are operating at a loss. So let's look at this. The antiderivative. Find the total profit when 60 seats are sold. Okay, so 0 seats to 60 seats. Our function, and I'm going to go ahead and rewrite it. Remember, square root of x is the same thing as x to the 1/2 minus 6. Okay, so my antiderivative will be x to the 3/2 multiply by the reciprocal minus 6x. Okay, and then we need to evaluate that at 0 and at 60. So we have minus 60. So we get, when we input 60 in, and remember these are in hundreds of dollars, so we get negative 50.16 hundreds of dollars minus 0 when we input 0. Okay, and we're going to multiply that number by 100 so we get what the actual dollars are, which is negative $5,016. That means we are operating at a loss of $5,016. Okay, and that's what it tells you on the next page. Okay, if you want to do this last word problem, again, the answer will be in the notes posted online. It should have all the answers. You can